We are surrounded by radio waves. While the hiss you are hearing from this analog radio is mainly noise generated from its circuitry and interference from artificial sources, a small fraction of this noise is actually coming from our distant universe. Radio waves, especially those at the 21 centimeter wavelength, have become essential to the field of astronomy. Our typical narrow spectrum of visible light is often obstructed, and many celestial objects don't even produce visible light waves. But radio waves are not blocked as easily and can offer information about galactic structure, universe expansion, and the cosmic dawn. One of the most useful phenomena that produces this 21 centimeter radio wave is neutral hydrogen spin flip transition. So, what exactly is happening out there? Hydrogen is the most abundant element in our universe. Here is a hydrogen atom with one proton and one electron. Both of these subatomic particles have certain properties, such as mass, charge, and quantum spin. It's important to note that the proton and electron are not actually spinning. Rather, quantum spin is an intrinsic, quantized property of the particle that describes its angular momentum. By the laws of quantum mechanics, our proton and electron must either be spin up or spin down. In its lowest energy state, hydrogen will have a proton and electron with opposite spins. But through collisions with other atoms, hydrogen can acquire a small amount of energy that will cause the spins to align. Now, neutral hydrogen is in a slightly excited state. If we leave this atom alone for, say, roughly 10 million years, the electron will flip its spin back to the lower energy or ground state configuration. Atoms like to be in a stable state. This is the spin flip transition. And as hydrogen moves from a high to low energy state, the equivalent energy difference between these two states will be emitted in the form of a photon with a wavelength of 21 centimeters and a frequency of 1420.4 megahertz. Given all these conditions, it may seem that the probability of this occurring is unlikely, but there are a lot of hydrogen atoms in the universe. So at any one time, a fraction of these atoms will be in this excited state, and a transition will take place, sending out radio waves that we can track. The observation of the 21 centimeter line marked the birth of spectral line radio astronomy. We've since mapped our galaxy, detected signals from the cosmic dawn, and through Doppler shifts even proven that our universe is expanding. Radio astronomy and the spin flip transition are the keys to solving some of the biggest mysteries about our origin and what lies beyond Earth's atmosphere.